Okay, good day everyone. So for this video, the topics that I will be discussing will be about the equivalent circuit per phase of an alternator, resistance test on alternators, open circuit test on alternators, short circuit test on alternators, the alternative parameters derived from the open and short circuit test results, and lastly, all about the voltage regulation. So just a quick recap about what we have discussed from our previous meeting. So we have discussed that again alternator, that is what we call the AC generator, no? So it is a generator that delivers an AC voltage to the load. So we have discussed the topics about the frequency of voltage in an alternator, the generated voltage in an alternator, about the coil span, the pitch factor, the distribution factor, and lastly, the corrected voltage of an alternator. So today, I will discuss to you these 6 other topics under the AC generators. So first is about the equivalent circuit per phase of an alternator. So this is our 3-phase alternator. So we have this EP, or that is the induced EMF per phase, no? So natay tulo ka line dere. This EL kani siya mo ni siya ang ato ang line voltage, no? So this is actually line to line, no? From kaninga line, if we call this A, B, C, so line A and B, so across ana is your line voltage. Ang phase voltage, no, kani siya mo ni siya ang atong per phase nga voltage, no, kani. So sa B and sa C. So line to line man, so natay line A, B, naputay B, C, and AC nga line nga voltages. Then this is its equivalent circuit in per phase, no? Kung magwa tag isa ani, this is one phase, no? Kaduha din ikatulo. So magwa tag isa lang ani nila, then mo ni siya iyahang equivalent circuit per phase. So we have this DC source, this field windings, no? Natay EP nato, no? Kani-kani-ganiha, which has our RP. RP is the resistance of the winding per phase. And we have this JXP, no? Diba R is resistance, X is the inductive nga resistance, no? Or katong imaginary nato nga resistance. Then we have our load and VP. So the equation for our EP, no, kani siya, EP with which has an angle of gamma is equivalent to VP angle 0 plus IP angle positive negative theta multiplied by RP plus JXP. No? So, dili ta ma-confuse sa EP ug sa VP ha. So, EP, that is the induced EMF per phase, while ang VP, that is the terminal voltage per phase. No? So, this is our EP, then this is our VP. Then, the gamma here, that is actually the power angle, and that is the angle between the EP and the VP. While kaning IP, I sub P, no? Nganon naman ang mga Pser that denotes nga per phase ni siya nga mga values mo nang naka P. So current per phase. Then this here we have positive and negative nga theta. It is positive if ang atong load PF is, or power factor is lagging. And if our power factor is leading, then it is negative theta. Then RP, again, that is the resistance of the winding per phase. Then atong XP, that is the inductive reactance of the winding per phase. So unsa ganin ni siya? Familiar, R plus JX, that is actually our impedance, or that is equal to ZP, no? Atong impedance that is denoted as ZP. Okay, so let's have example. Example number 1, a 1000 kVA 4600 volts three-phase Y-connected alternator has an armature resistance of 2 ohms per phase and a synchronous armature reactance of 20 ohms per phase. So find the full load generated voltage per phase at a power factor of 0.75 lagging, no? So since ang ato ang problem, it's stated here that it is connected in Y, no? Y connected siya or star connected, no? So meaning ang atong IP or ang atong current per phase is just equal to our line nga current, no? So they are just equal. So we have this formula, IP is equal to S over square root of 3 VL. No, sa ganinang S, S is our apparent power and that is given by 1000 kilovolts, no? So IP is equal to our apparent power divided by square root of 3 of VL. Nga naman nag-multiply tag square root of 3 dere because our given value here is in line, no? Then atong gisolve dere nga current is phase. That's why we have to multiply it by square root of 3. So apparent power is given by 1000 kilo, or that is equivalent to 1 times 10 to the power of 6 over square root of 3 times our given VL, no, line voltage, that is 4600. So 1 times 10 to the power of 6 divided by square root of 3 times 4600, that is equivalent to 125.51 amperes. Next is to solve for our VP. VP is equal to, we have 4600 over square root of 3, no? And that is equal to 2655.81 volts. Then next is to solve for our theta, no? Given tag 0.75, the formula for the power factor is cosine theta, the angle is equal to our given nga power factor. So since we have a power factor of 0.75, no? Then to solve for our theta, ato siyang i-inverse, no? So naatay cosine inverse of 0.75. So mabilin dari is si theta. So para aha ganin theta para sa angle sa ato ang current. So again, we have the formula EP is equal to VP plus IP times ZP. So anak ko niyo ganiha. This one, kaning RP plus JXP is actually equal to ZP or the impedance. No? So we have VP. So natay VP nakuha ganiya nga 2655.81 angle 0 plus our IP, no, natay nakuha nga 125.51 angle. So nga negative man because ang ato ang power factor is lagging, no? Nata diri nakabutang wait. Should be negative. laging baliktad. Sorry. Kuha na siya. Baliktad si lagging og si leading. Kanina lang ano. I will edit this later. So ang negative si lagging, then positive si leading na angle. Okay. So, unsa to? Ngano to siya na negative 41.41 because the given power factor is lagging. So, 125.51 angle, negative 41.41 multiplied by our ZP. So, unsa ganing ZP? This is actually equal to R plus JX, no? Then, given ta og R, which is equal to 2, no? Anatay armature resistance. Then naatay reactance, no? Reactance is our X. So that's why we have 2 plus J20. So pag type ani sa calculator, this is 2 plus 20i. No, sa calculator. 20i na siya pag type. Wala may J dira sa calculator. Okay. So your answer for that should be equal to 4,820.43 angle 20.86 degrees. So this is already our voltage per phase, no, kay EP man na. So final answer is 4,820 volts. Okay, so let's proceed to another example. Example number 2. A three-phase synchronous generator has negligible resistance and synchronous reactance of 2 ohms per phase. It is operated on an infinite bus having a voltage of 15 kilovolts. The internal EMF and the power angle of the machine are found to be 24 kilovolts line to line and 25 degrees respectively. No power angle of ang internal EMF. So determine the total megawatt hour delivered by the system. So megawatt hour meaning the power or the total power delivered by the system. Ang nato ang pangitaon. So first is natay given nga 15 kilovolts, no? So that is usually basta given og mga ingani, this is understood that it is in line voltage, no? That is 15 kilovolts. So that's why you have to convert it into phase voltage. We have 15,000 divided by square root of 3. So we have an answer of 8,660.25 volts. Then to solve for our EP, we have EP. This is the internal EMF, no, equal to 24 kilovolts. So again, line to line Japon siya. So to convert it into per phase, so you divide it by square root of 3. So 24,000 divided by square root of 3, that is 13,856.4 volts. After that, we substitute it to our formula, no? EP is equal to VP plus IP times ZP. Then we manipulate our formula to find the value of our IP, no? So ato lang ni i-transfer si VP sa pika side sa tong equation. So it will make the equation EP minus VP, no? Mabalin siya sa pika, so ma-minus siya. After that is you divide both sides sa equation by ZP para ma-cancel. Ang mabilin daring equation is only IP. So mo nang IP na lang mabilin. So the other side's equation ma-divide siya og ZP, no? Next is to substitute the given values, no, and our computed values. So naatay computed nga EP, no, induced nga voltage per phase equal to 13,856.4. Then na po siya given nga power angle which is equal to 25 degrees. We subtract it by our VP, and remember that VP has zero angle, no? So that's why automatic na siya. So we have 8,660.25 angle 0 divided by our ZP. So natay gibutang dari nga reactance nga 2. So itong reactance, that is our X. Then ang resistance nato kay negligible daw nga resistance. So that means natay resistance nga 0. So 0 plus J2 actually na siya, no? Or in short, that is actually J2. So solving this, again ha, sa calculator this inyong pagsulat is 2i, no? Then dapat naka-degrees ang inyong mode sa calculator. So solving this one, we have the answer for our IP, or current per phase, equal to 3,517.3 angle negative 33.64. After that, we substitute that into our formula. So actually, I think this has already been discussed, no, sa inyong 132 sa circuits 2 ninyo about AC, three phase, no, nga AC. So ang power ana, no, pag determine sa atong power is actually equal to 3 times VI, di ba? Natay sa DC, power is computed as current times voltage. But sa AC, the same lang nga I times V, but nanatay kauban nga angle, or di kaniyatong power factor, which is the cosine theta, no? PF power factor mo na siya equal ni cosine theta. Ayun yung kalimti. And 3 because total man, no, per phase man ang ato ang values. So i-multiply nato siya og 3. Kaya tong given nga problem is naka 3 phase. So we have 3 times our values atong VP, which is 8,660.25 multiplied by our IP, which is magnitude sa atong IP, no, atong gikuha, which is 3,517.3. Then ang angle sa ato ang current mo na siya itong i-substitute sa ato ang theta. Okay? So that's why we have cosine of 33.64. So the answer for that is 76 megawatts, or 76 million watts. Okay. So next is we will talk about the resistance test on alternators. So the test is used to determine the resistance of the alternator windings per phase, no? Per phase nga yahang resistance. With the DC field winding open, no, kaning DC field nato kay naka-open siya, measure the DC resistance between each pair of the terminals, no? So nata isa ka terminal dari, isa ka terminal dari, then you measure the resistance. Then the average of the 3 sets of resistance value is what we called the RT, no? RT is the resistance reading of the DC ohmmeter. And kaning RP, that is the distance, DC resistance of the armature winding per phase. Okay? So RT katong resistance average of the 3 sets of resistance values, no? Nakabutang dari. So ang relationship ana nila is if Y connected winding, RP kani RP is equal to 1/2 of the RT. So that is if it is Y connected. If it is delta connected winding, then our RP is equal to 3/2 of the RT. And take note that in practice, it is customary to multiply the DC resistance Rp by a factor of 1.25 to 1.75 to obtain a value more nearly equal to the armature resistance when it carries alternating current. Okay. So next is about the open circuit test on alternator. So kaganiha resistance test sa alternator. So atong makuha ato is ang resistance no. Ang open circuit test sa alternator. So this with the armature winding circuit open, the alternator is operated at synchronous speed, no? So ang armature winding circuit kay naka-open dayon the alternator or the AC generator is operated at synchronous speed. The field is adjusted so that the AC voltage between any pair of the terminal is a little above the rated line voltage of the alternator. So in Y-connected windings, the open circuit voltage per phase no kaning OC, that means open circuit no voltage, is equal to V, that is the reading sa mga voltmeter, divided by square root of 3. Then sa delta connected winding naman, so since ang ato ang kuano kaning EOC is just parallel sa ato ang voltmeter, meaning the value nga makuha nato sa tong voltmeter is just actually uh, equal to the value sa ato ang EOC, no? Kay parallel raman sila. Di ba sa voltage, if they are parallel, equal lang ilahang value nga makuha, no? That's why mora na inyong timan-an, no? Equal si voltage sa open circuit sa imong voltage sa imong voltmeter reading if delta connected, and if Y connected kay V over square root of 3 ilahang relationship. So for short circuit test naman sa alternator, kung kaganiha sa resistance test, makuha na to ang resistance. Sa open circuit test, makuha na to ang voltage. Then sa short circuit test, ang atong makuha diri is the current, no? Short circuit the three terminals of the alternator and connect three ammeters in each line to monitor the short circuit current. Then run the alternator at rated synchronous speed starting with 0 excitation, then gradually increase the excitation until the ammeters will read the rated line current. No? So for the Y connected, 'di ba pag naka-series siya, ang iyang current kay equal. Now since ang ato ang ammeter kaning A diri, this is our ammeter. This is in series, no? Sa ato ang isa ka line, meaning our current here will just be the same nga current nga mo-flow ani niya. That means ISC is just equal to the A. A is the sige to armature ay ammeter reading, no? Reading sa tong ammeter. So sa delta connected naman is kabaliktaran, no? Ganiha sa ato ang open circuit test. So our current, no, sa short circuit is equal to the ammeter reading divided by square root of 3. Okay? So nanatay resistance, nanatay voltage o nanatay current. So next is the alternator parameters derived from the open and short circuit test results. So di ba ZP this is derived actually from katong duha ka test, no, sa sa short circuit o sa open nga circuit test. No, sa ito, sa short circuit, gi-short na to ang tulo ka line, no? Gi-short na to siya dari dayon sa open circuit kay gi-open na to ang mga lines. So ZP, that is the impedance, is actually equal to to the voltage no sa to ang open circuit over the short circuit nato nga current no. And remember sa ang relationship ni impedance is actually equal to the resistance plus our reactance no. So pag manipulate ani, this is actually equal to ana no yang relationship. So pag imong ibalhin ni si R sa pika side sa atong equation, so may mo siyang negative. So mabilin is si x squared is equal to z squared over minus r squared, no? Then take the square root para makancel c squared, so makancel. So mabilin na ra kay si z squared minus r squared, no? So gingana pag derive aning si reactance. Okay, so muna ilahang relationship ni impedance ug ni short circuit ug ni open circuit nga test results. So example, so the following are the test results on a three-phase star-connected alternator. So star connected atong alternator, then three-phase siya. So sa open circuit test, iyahang voltmeter reading kay 2,300. Sa short circuit test, ang ammeter reading nato is 204. Okay? Resistance test naman nato sa atong ohmmeter reading kay 0.8 ohms. No, nata given nga mga test results, natay tulo ka test results. Then assume that the effective AC resistance is 1.5 times the DC resistance, no? Ang effective nga AC resistance daw kay 1.5 times ato ang DC resistance. Determine the equivalent complex impedance of the alternator per phase. So, unsa gito impedance, no? Complex impedance meaning katong R plus JX ang ato ang pangitaon. So, ang atong pangitaon ani is ang value ni R ug ang value sa ato ang X, no, or sa atong reactance. So note that our alternator is connected in star connected, meaning kung may star connected, that is Y connected, no? Itong ana ang forma Y, nagpa-Y ang connection niya. So unsa man atong duha ang atong gamiton, di ba naman kay naatay 1/2 RT o 3 halves nga RT. So since Y connected siya, so atong gamiton is 1/2 nga RT. And since ingon diri nga the AC resistance is 1.5 times the DC resistance, no? So this is our DC resistance and this is our AC resistance. So you multiply it by 1.5, then the 1/2 RT, no? Then we substitute the value sa atong RT, which is 0.8 ohms. Tara, 0.8 ohms. So 1/2 times 0.8 times 1.5, that's equal to 0.6 ohms per phase, no? Because of this kaning pino RP. So that is per phase nga resistance. Next is nanatay R. So okay na si R. Kuha na lang nato is si X. So aha man nato ni makuha si X. So this is from the katong relationship, no? Kay given man ta og open circuit test nga result og sa short circuit test nga result. So kuha na to si Z or the impedance. Then pag makuha na to si impedance, magamit din nato ning second nga formula diri, no, to solve for our X or sa atong reactance. So our impedance per phase is equal to the result sa ato ang open circuit test over sa current sa ato ang short circuit nga test. So we have 2,300 volts. Then again, since ang atong nakuha ato is in line voltage ang atong nakuha, no? So we divide it by square root of 3. So we have V over square root of 3. No? So mo nang we have V over square root of 3. So we have 2,300 over square root of 3. Then remember, in Y connected, no? Kay ang ato ang current is actually just equal, no? The same ra ang ato ang current nga flow nga makuha na. So that's why our A is directly the value of the result, which is 204. So 2,300 divided by square root of 3 over 204. So the answer for that is 6.51. Then we solve for our reactance. So that is equal to the square root of our impedance squared minus our resistance squared. So we have 6.51 squared plus 0.6 squared. Then you take the square root of that answer. Then nanatay result nga 6.48. So now we can solve for our complex impedance na dayon. So complex impedance is equal to R. R na to is 0.6 kanina plus our JX, no, which is equal to 6.48. Okay, so next is about the voltage regulation. No, so the percentage voltage regulation is the percentage rise in voltage in the terminals of the alternator after the load is switched off. No, and the formula in solving for the percentage voltage regulation is equal to the E no load minus full load over full load, no? Or that is EP minus VP over VP. And again, sa kitong EP, that is the induced EMF per phase, no? Kani, this is the EP. Then VP is the terminal voltage per phase, no? Kana sa tong load. This is our load. Okay? And there is an alternate formula using the per unit data. So if you have a per unit data, so you may use this in solving for the percent voltage regulation. No? So that is equal to the square root of cosine theta plus per unit, no? Per unit sa ato ang uh, resistance squared plus sine theta, then we have this plus or minus sign of our per unit naman sa ato ang reactance squared minus 1. So the same lang, if positive siya, that is lagging, and if negative naman siya, it is leading, no, sa paggamit anemia. So if the PF is lagging, so if the given PF is lagging, then you expect that the voltage regulation is a positive value. While if ang PF naman is leading, then you expect that the voltage regulation is a negative value. So let's have examples. So a three-phase 50 Hertz star connected 2000 kVA 2300 volts alternator gives a short circuit current of 600 amperes for a certain excitation. So this is ISC, no, short circuit nga current. So unsa man ni si 2300 volts. So this is our VL, no? Then kaning si 2000 kVA, this is our S, no? That is the apparent power. So 50 hertz, that is our frequency, no? Kani mo ni siya to ang phase. So it is important nga kabaluta kung unsa ni sila nga mga values. So with the same excitation, the open circuit voltage, so this is our EOC, no? This is our EOC. The resistance between a pair of terminals is 0.2 ohms. Then we are asked to find the full load voltage regulation at 0.8 power factor lagging, no, lag. So how do we solve that? So ato ang formula no sa atong percent voltage regulation is EP minus VP over VP. So ang atong goal is to find the value of our EP and our VP with this given nato nga mga values. No? So first, para sa VP, so sa yun ra no, given ka og line voltage. So to find for its voltage nga per phase, so i-divide lang nimo to siya into square root of 3. Now we have 2,300 divided by square root of 3. So automatic na tayo voltage per phase nga 1,328 volts. Then how about sa ato ang EP? No, so itong first discussion natay formula nga EP is equal to VP plus IP times ZP. No, nataani nga formula itong pinakauna nato nga topic. No? So to find EP dapat pangitan nato si IP which is naa natay value niya. Pangitan nato si IVP na natay VP, IP atong pangitaon and si ZP. No? So using the formula, again, since this is star connected, no, Y connected, bali siya, or star connected. Ang isa kay delta na siya, delta connected. So this is star connected or Y connected, no? So ang atong gamiton is katong RP is equal to 1/2 times RT. No, dili tong 3 halves kaysa delta man to. So we have 1/2 times 0.12, tara, 0.12 na to nga resistance between the pair of terminal, no, manang RT. So RRP is equal to 0.06 ohms. Then for our ZP, no, namatay given nga EOC ug ISC, no. Then since this is Y connected, so dapat ang ato ang voltage ato siya divide og square root of 3. So that's why we have 900 divided by square root of 3. Then ang ato ang ISC kay equal ra siya no kay Y connected man. Equal ra ang ato ang current. So we have our answer here sa ato ang impedance which is equal to 0.866 na ohms. Then we solve for our reactance no using the formula nga discuss ganiha, that is impedance squared minus the resistance squared, no? Ato lang dayon substitute ang value. I think minus ni siya dapat. Murag mali. Sorry. Check ha. So that is yes, that should be minus. So 0.866 squared minus 0.06 squared. Then take the square root of that. So our XP is equal to 0.864 ohms. No, nantay XP. So from that, ganin ni siya magamit. So si XP magamit ni siya sa ZP. Kay si ZP is equal to RP, no, resistance per phase, plus J, then reactance per phase. No, so dari na siya magamit niya. So unsa nalay ko lang nato na natay ZP, no, na natay VP. So atong isolve na lang is si IP. So saan ganin na si IP? So the same formula that we used kaniha. So IP is actually just equal to our IL, no? Line current na to ug atong phase current kay equal siya since it is Y connected, no? The same ra ang current nga mo flow sa atong line ug sa to ang per phase. So that is given as the apparent power over square root of 3 times our line voltage. Now we have this 2 million, or that is katong 2,000 kilo man. So this is 2,000 times 10 to the power of 3. So that is equal to 2 million. Divided by square root of 3 times our VL, no, given man tag VL nga kani. This is our VL nga 2,300. So our IP, which is equal to IL, is equal to 502 amperes. Then natay given nga power factor nga 0.8. So para ma-solve na to ang angle sa to ang current, no? Kailangan mato i-solve ang angle sa tong current. So we just take the inverse cosine of our power factor. So ani inverse cosine ni 0.8 is equal to 0.8. So this is 36.83. 87. 36.87. So nanatay values no nga atong mga kailangan ng mga values, so i-substitute na nato siya sa atong formula. So that is VP. So VP nato angle 0 jud na siya. So we have VP na 1328 angle 0 plus our IP. So magnitude sa atong IP is 502. Then yung angle is negative 36.87. Ngano gito negative? Because atong power factor is lagging, no? Lagging. So negative. Multiplied by our ZP. So ZP mo siya ang R plus JX, no? Value sa tong RP, that is 0.6, tara. Then sa to ang X, that is 0.864. Then ang atong makuha nga result ana is ang atong IP na dayon, which is 1645.447 angle 11.53. And to solve for our percent voltage regulation, no, natay EP minus VP over VP, i-substitute lang nato ang magnitude. Magnitude lang ha, walay apil ang angle. So magnitude nga 1645.447 minus the value of our VP, which is 1328, divided by 1328. So our answer here is 23.904%. So i-times pa ni siya 100%, no? Ang 1645.447 minus 1328 divide 1328. So ang answer na is 0.2390. So i-times pa na ni mo 100 para makuha na to ang 100% niya, ang percentage niya nga value. So that is 23.904%. Okay, so let's have another. This is the alternate solution using the alternate formula, no, if given ka og per unit nga mga values. So first nimong buhaton is to find the impedance value niya in per unit, and that is given as S rated times the Z impedance nato per phase over the E rated nato, no, sa line to line nato squared, and that is equal to 2 million mao man itong S. Then na-solve na nato ganihang ZP, so wala na ako gipakita dere. So again, ZP nato is 0.866, no? So manang 0.866 dili tara. ZP tara. Kani kuan di ay complex nga impedance sa itong gamiton, which is 0.06 plus J 0.864. No, complex nga impedance over our E-rated, no, that is in line to line, no, this is already in line to line man siya, no, so mana ning 2,300 squared. So our answer for that is 0.02268 plus J 0.3266. Then we have cosine theta of 0.8. So yun sa may pagkuha si 0.6. So di ba natin na-solve ganiha nga angle of ang angle ani inverse cosine ni 0.8 is 36 point pila to? 87. So sine lang, sine ni 36.87. So na may result ana nga makuha nga 0.6. So makuha nimo ning value si 0.6. Then again, mo na siyang alternate formula, no, given sa to ang voltage regulation. So we have i-substitute lang na to, square root of the cosine theta plus, this is the, katong akong giingon no, the resistance in per unit plus sine theta plus per unit na tong reactance squared minus 1. So, substitute lang cosine theta, that is 0.8 plus atong per unit nato nga resistance, that is tara no, per unit nga ni nga impedance. So kaning R dari mo ni siya tong per unit nga resistance. Then ang ato ang kani, this is actually ato J x per unit, no? So kani nga value, this is our per unit nga resistance squared plus sin theta is 0.6 plus our per unit na pod nga reactance, that is 0.3266 squared. Then don't forget si minus 1 sa end. So si minus 1 ha, wala ni siya na-appeal sa square root. So our answer here is 23.91. So pare-parehas ra siya sa result nato ganihan, no, which is 23.904%. So dool ra. Okay. So for your assignment, so I have these two problems, no? Answeran ninyo, then deadline for this will be next Thursday. So for number 1, a 60 MVA 69.3 kilovolts three-phase synchronous generator has a synchronous reactance of 15 ohms per phase. Wait lang. Okay. And negligible resistance, so R is equal to 0. Then the generator is delivering rated power at 0.8 PF leading at rated terminal voltage to an infinite bus bar. So the question is to determine the what is the magnitude of the wait lang, magnitude or kwan? Magnitude sa yung power angle, no? So ang power angle ang makita na. So hint, your answer should be 9.59 degrees. Na? So dapat na yung answer. Next is number 2, a three-phase Y-connected 318.75 kVA 2,300 volts alternator has an armature resistance of 0.35 ohms per phase and a synchronous reactance of 1.2 ohms per phase. Then solve for the regulation, no, VR, percent VR mo pangitaon ani at full load, kVA if you are given with natay duha ka condition. So sa letter A, duha dapat yung answer ani. Sa letter A kay natay 0.8 PF lagging and rated voltage, then ang isa is 0.6 PF nga leading. So mo kalainan nila ang power factor nga given. So next week we will have our exam on Thursday. Then that's the time also that you are going to submit your assignment 1 and assignment 2. Then by Monday and Tuesday we will continue our discussion about AC generators, so that on the following week we will have our second exam. Then the coverage for that is the entire topic of AC generator. So that's all for this video. Thank you guys for listening.